What's the connection?
Because logarithms are really exponents, they satisfy all the usual rules of exponents. Consequently, tedious and long algebraic calculations such as those involving multiplication and division can be replaced by the simpler processes of adding or subtracting the corresponding logarithms. In general, logarithmic tables are usually used for this purpose, although calculators, computers, and the Internet often replace the need for such tables.
What are Kepler's laws of planetary motion?
A great deal of mathematics went into the formulation of Kepler's laws of planetary motion. These laws were devised by German astronomer and mathematician and Danish astronomer Tycho Brahe's 1546–1601 assistant, Johannes Kepler, 1571–1630. He presented the first and second laws in his work Astronomia Nova, New Astronomy. In 1609, the third law was published in 1619 in Harmonis Mundi. The three laws are as follows. Kepler's first law, or law of elliptic orbits: each planet moves about the Sun in an orbit that is an ellipse, with the Sun at one of the two foci of the ellipse. Kepler's second law, or the law of areas: an imaginary straight line joining a planet to the Sun will sweep out equal areas of the ellipse in equal periods of time. Kepler's third law, or the harmonic law: the square of the period of a planet's revolution is directly proportionate to the cube of the semi-major axis of its orbit.
What is a perfect square?
Here are many equations that can be factored into a perfect square. Any expression written in the form x2 plus 2x and a 2 is a perfect square. An expression writ 210 as something. To determine if an expression is a perfect square, first see if the constant term is a square number. In other words, can the square root of the number be taken to get an integer for an answer? If so, determine if the square root of the constant multiplied by 2 gives the coefficient of the linear term, or the x term. If it does, the original expression may be factored into a perfect square. Note, the above procedure only works when the coefficient of x2 is 1. For example, in the equation x2 plus 8x plus 16, the constant term, 16, is already a perfect square. The square root of 16 is 4. Since 2, 4, equals 8, the original expression can be written as a perfect square. Because we know x2 plus 2x and a 2 is a perfect square, and equals x and a 2, by substituting the common factor 4 into the equation, we find that x2 plus 8x plus 16 equals x plus 4, 2.
What is the connection between counting and mathematics?
Although early counting is usually not considered to be mathematics, mathematics began with counting. Ancient peoples apparently used counting to keep track of sundry items, such as animals or lunar and solar movements. But it was only when agriculture, business, and industry began that the true development of mathematics became a necessity.
Are there different types of functions?
Yes, there are different types of functions, so many. In fact, that the topic of functions is a book in itself. In particular, algebraic equations include polynomial and rational expression functions. For example, polynomial equations include linear, first-degree, functions, such as f, x equals 2x, a quadratic, second-degree, function example is f, x equals x2. But algebraic and polynomial functions are not the only use of the term function, so don't get confused. There are also non-algebraic functions called exponential functions, and the inverses of exponential functions, which are called logarithmic functions. Set theory emphasizes the use of functions. For more about functions and sets, see Foundations of Mathematics. And there are trigonomic functions that include the relationships of sine, cosine, and tangent functions. For more information about trigonometry, see geometry and trigonometry. There also are continuous or discontinuous functions, transcendental functions, and even real and complex functions. All this may or may not be connected to algebra. The list goes on, but it is easy to see that mathematicians love the word function.
What are the probabilities and odds of being initially dealt certain hands in 5-card poker and bridge?
Because there are a certain number of cards in a playing deck, mathematicians have worked out the probabilities and odds of being dealt certain hands for certain games. The following explains the odds in terms of chances against, chances for.
Why were early Greek calendars such a mess?
And like the Mesopotamian cultures, the early Greeks paid less attention to astronomy and more to cosmology. They were interested in studying where the Earth and other cosmic bodies stand in relation to the universe. Because of this, their astronomical observations were not accurate, creating confusing calendars. This also led to a major conundrum: almost every Greek city kept time differently. In fact, during the Greek and Hellenistic times, most dates were given in terms of the Olympiads. This only created another timekeeping problem: if something happened during the 10th Olympiad, it meant the event occurred within a 4-year span. Such notation creates headaches for historians, who end up making educated guesses as to the actual dates of Greek events. important people's deaths and births, and other significant historical occurrences.
What is the least squares method?
This mathematical procedure, called either the least squares method or the method of least squares, finds the best fitting curve for a given set of points by minimizing the sum of the squares of all deviations from the curve. It is often used in engineering for fluid flow, certain elasticity problems, and diffusion and convection in materials.
How else is the term function used?
Unfortunately, as with many mathematical terms, there is often more than one function for the word function. For example, contrary to the definition above, function can also mean the relationships that map single points in the domain to multiple points in the range called multivalued functions, which is mainly used in the theory of complex functions. To further confuse matters, there are also functions called non-multivalued functions.
What types of analyses interest engineers?
There are several types of analyses that interest engineers, all of which involve mathematical modeling. Structural analysis deals with linear and nonlinear models and stresses on a material. The linear models assume the material does not plastically deform, the remaining deformation after the load causing it is removed. Nonlinear models stress the material past its elastic capabilities. The stresses in the material then vary with the amount of deformation. Vibrational analysis deals with possible resonance and subsequent failure. It is used to test a material that may experience random vibrations, impacts, or shocks. Fatigue analysis is used to determine the life of a material or structure. It shows the effects of occasional, periodic, or cyclic loading on a structure or object, pointing out where cracks or fractures are most likely to occur. Engineers measure heat transfer to determine a material or structure's conductivity or thermal fluid dynamics. In this way, researchers understand how a material will respond to various hot and cold conditions, or even how it diffuses heat and cold over time.
What is prime factorization?
Many of us are most familiar with prime factorization, which is a way of taking a number and breaking it down into its constituent primes. An example of prime factorization is as follows: one finds the simplest representation of the given quantity in terms of smaller parts. In the case of 15, the factors would be 1, 3, 5, and 15, essentially all the numbers that will divide integrally into 15. Not that prime factorization is always that easy. Larger numbers make it more difficult to factor. And many sophisticated prime algorithms have been devised for larger and different types of numbers.
When was a mechanical calculating device first used for the American census?
When government officials estimated that the 1890 census would have to handle the data from more than 62 million Americans, there was a slight panic. After all, the existing system was slow and expensive. Using tally marks in small squares on rolls of paper, which were then added together by hand. One estimate determined that such an endeavor would take about a decade to complete, which would be just in time to start the process all over again for the 1900 census. In desperation, a competition was set up to invent a device that could easily count the 1890 U.S. Census. Thus, in the 1880s, American inventor Herman Hall Erith, 1860 to 1929, who is also known as the father of modern automatic computation, presented his competition-winning idea. He used Jacquard's punched cards to represent the population data. Then read and collated the information with an automatic machine. With his automatic tabulating machine, an automatic electrical tabulating device, Hollerith would put each individual's data on a card. With a large number of clock-like counters, he would then accumulate the results. From there, he would use switches so the operators could instruct the machine to examine each card based on a certain characteristic, such as marital status, number of children, profession, and so on. It became the first such machine to read, process, and store information. The machine's usefulness did not end there, though. Eventually, Hollerith's device became useful for a wide variety of statistical applications. Certain techniques used in the automatic tabulating machine were also significant, helping in the eventual development of the digital computer. Hollerith's company would also eventually become well known, becoming International Business Machines, or IBM, in 1924.
What is a geometric series?
If we add the numbers in a geometric sequence, we end up with a geometric series. A geometric series is obtained when each term is determined from the preceding one by multiplying by a common ratio. There is a constant ratio between terms. For example, 1 plus 1/2 plus 1/4 plus 1/8 plus, and so on, is a geometric series because each term is determined by multiplying the preceding term. By January 2nd. To find the sum of a geometric series, the formula is, sum equals a, rn1, slash, r1, or a, 1 rn, slash 1r, in which a is the first term, r is the common ratio, and n is the number of terms. For example, To find the sum of the first 6 terms of a series represented by 2 plus 6 plus 18 plus 54 plus 162 plus 486, define A equals 2, R equals 3, and N equals 6. Substitute the numbers, sum equals 2, 36 1, slash 3 1 equals 729 1 equals 728. We could also have determined this number based on the first few numbers, such as 2 plus 6 plus 18 plus 54, as long as we knew the common ratio, the first number, and how many numbers in the series we wanted to add. This is something that can easily be determined based on just these 4 numbers.
What is Fisher's fundamental theorem of natural selection?
Evolutionary biologist, geneticist, and statistician Sir Ronald Aylmer Fisher. 1890 to 1962, first proposed Fisher's fundamental theorem of natural selection in 1930. A mathematical concept. It states that the rate of evolutionary change in a population is proportional to the amount of genetic diversity available. He is also often credited with creating the foundations for modern statistical science.
What is spherical geometry?
Spherical geometry is the study of objects on the surface of a sphere. This differs from the type of geometry studied in plane or solid geometry. In spherical geometry, there are no parallel lines. And straight lines are actually great circles, so any 2 lines meet in 2 points. In addition, the angle between 2 lines is the angle between the planes of the corresponding great circles. There are also entities called spherical triangles, or Euler triangles. When 3 planes pass through the surface of a sphere and through the sphere's center of volume, they have 3 surface angles and 3 central angles. There are also spherical polygons, in which a closed geometric object on the surface of a sphere is formed by arcs of great circles.
What is environmental modeling?
As with most of the sciences, mathematical modeling and computer simulations also come in handy for environmental applications on a local, regional, and global scale. For example, scientists model environmental landscape changes, global climate change and the impacts on ecosystems, watershed and reservoir interactions, and forest management and sustainability.
Are there different types of proofs?
There are several different types of proofs in mathematical logic. Direct proofs are based on rules that result in one true proposition from 2 propositions. They show that a given statement is true by simply combining existing theorems with or without some mathematical manipulations. For example, if you have two sides of a triangle with the same length. A definition and theorem show that a line bisecting their vertex produces two congruent triangles, a direct proof that the angles at the other two vertices have the same size. In logic, indirect proofs are also called proofs by contradiction, and are known in Latin as reductio ad absurdum, reduced to an absurdity. This type of proof initially assumes that the opposite of what you are trying to prove is true. From this assumption, certain conclusions can be drawn. One then searches for a conclusion that is false because it contradicts given or known information. Sometimes, a given piece of information is contradicted, which shows that since the assumption leads to a false conclusion, the assumption must be false. If the assumption is false, the opposite of the conclusion one is trying to prove, then it is known that the goal conclusion must be true. All of this has therefore been shown indirectly. Finally, a DISP proof is a single instance that contradicts a proposition. For example, the DISP proof of all primes are odd is the true statement the number 2 is a prime and not odd. If a DISP proof exists for a proposition, then the statement is false.
What are ratios and proportions?
A ratio is the comparison of two numbers. It is most often written as a fraction or with a, as in 3/4 or 3:4 to separate the two numbers. For example, if we want to know the ratio of dogs in a shelter that houses 24 animals to the total count, we first determine the number of dogs, say, 10, then the ratio of dogs to animals in the shelter becomes 10/24, or 10/24. Which is also said as 10/24. But there are rules to ratios. For example, order matters when talking about ratios, therefore, the ratio 7:1 is not the same as 1:7. A proportion is an equation with a ratio on each side, and is a statement that two ratios are equal. For example, 1/2 equals 4/8, or 1/2 is proportional to 4/8. In order to solve the proportion or when one of the four numbers in a proportion is unknown, we need to use cross products to find the unknown number. For example, to solve for x in the following, 1/4 equals x/8, using cross product, 4x equals 1x8, thus, x equals 2.
What is a nonlinear differential equation?
From above, we know that linear equations have specific rules. For example, the unknowns y, and so on, will never be raised to a power more than 1, they will not be in the denominator of a fraction. Y times y is never allowed, because two unknowns multiplied together is, in a sense, a power 2 of unknowns, and they won't be inside another function, such as a sine. But a nonlinear equation is much different, allowing for powers of 2, y equals y2. Multiplying differences, y equals x, and even being inside another function, y equals x sin y. Thus, the nonlinear equations are not as easy to solve as linear differential equations. But that does not mean they lack importance. In fact, because nonlinear equations are more realistic in describing real-life problems, they are much more interesting, and challenging, to mathematical and scientific researchers in many fields.
Who were the Egyptians?
The Egyptians rose to prominence around 3000 BCE in the area we now call Egypt. But their society was already advanced, urbanized, and expanding rapidly long before that time. Although their civilization arose about the same time that words and numbers were first written down in Mesopotamia. Archaeologists do not believe there was any sharing between the two cultures. The Egyptians already had writing and written numerals, plus. The Egyptian signs and symbols were taken exclusively from the flora and fauna of the Nile River basin. In addition, the Egyptians developed the utensils for writing signs about 1,000 years earlier.
Upon what system were ancient measurements based?
Initially, people used different measurement systems and methods depending on where they lived. Most towns had their own measurement system, which was based on the materials the residents had at hand. This made it difficult to trade from region to region. Measurements eventually became based on familiar and common items. But that did not mean they were accurate. For example, length measurements were often based on parts of the human body, such as the length of a foot or width of the middle finger. Longer lengths would be determined by strides or distances between outstretched arms, because people were of different heights and body types. This meant the measurements changed depending on who did the measuring. Still, they were close enough for the needs at the time. Even longer lengths were based on familiar sites. For example, an acre was the amount of land that 2 oxen could plow in a day.
What was the Sumerian oral counting system?
The Sumerians, whose origins are debated, but who eventually settled in Mesopotamia, used base 60 in their oral counting method.
What are other types of angles?
There are numerous other types of angles, some of which are examined in the following list. Adjacent angle. Adjacent angles are two angles side by side that have a common vertex. Endpoint, and ray, Angles are adjacent if a common line is between the other sides. Vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. Because of this, vertical angles have no sides in common and are directly across from one another. They are also considered a pair of opposite congruent angles where two lines intersect. Vertical angles include intersecting lines that define a plane. With the vertical angles always in the same plane. Congruent angles. Congruent angles have the same size and shape. Vertical angles are considered to be congruent. Exterior and interior angles. Interior angles are those inside a polygon, such as a triangle. Exterior angles are outside the polygon formed by extending one ray, side, outside the polygon from a vertex. Alternate and corresponding angles. A pair of angles that lie on opposite sides and opposite ends of a transversal. A line that cuts two or more lines in the same plane. Are called alternate angles. Both these angles are equal if the lines cut by the transversal are parallel. They are also broken into alternate interior angles, the inside angles, and alternate exterior angles, the outside angles. For two parallel lines, the alternate interior and exterior angles are equal or congruent. Corresponding angles are pairs of angles that lie on the same sides and ends of a transversal. Dihedral angle. A dihedral, meaning two bases. Angle is one of the four angles formed where two non-parallel planes meet. Complementary angles. Two angles that add up to a right angle are complementary. For example, the two acute angles in a right triangle are always considered complementary, as their sum adds up to 90 degrees of the right triangle. Supplementary angles. Two angles that add up to a straight angle, 180 degrees, are supplementary. If the angles are both supplementary to the same angle, then the two angles are congruent.
How are the simplest angles classified?
Angles are usually expressed in terms of rotation, in which a full rotation is equal in most cases to a 360-degree circle. Half of a full rotation is called a straight angle. A quarter of a full rotation is called a right angle, 90 degrees. An angle less than a right angle is called an acute angle. An angle greater than a right angle is called an obtuse angle.
What are the main parts and types of computers in use today?
The basic parts of a computer are the central processing unit, CPU, memory, a keyboard and other optional input devices such as a scanner, and output devices such as a screen, a printer, and audio speakers. The biggest differences between the various types of computers are the amount of memory and speed of the machines. It's also easy to see why the word computer has so many connotations. They vary greatly, but include the following basic types. which are based mostly on the size and number of people who can simultaneously use the machines. The mainframe is considered the largest and most powerful general-purpose computer system. It is usually used to fill the needs of a large agency, company, or organization, because it uses hundreds of computer terminals at the same time. Supercomputers are sophisticated machines designed to perform complex calculations at maximum speed. Because of their speed and the great amount of data they can work through, they are most often used to model huge dynamic systems with many variables, such as weather patterns and groundwater flow. Microcomputers are usually subdivided into personal computers, or desktop computers, and workstations. Oftentimes, microcomputers are linked together in a local area network, LAN, or by joining the microprocessors in a parallel processing system. This allows smaller computers to work in tandem, often giving them comparable power and computational abilities to mainframes. Familiar to many people today are notebooks and laptops, which are very similar. Laptops are small enough to fit on a person's lap. Notebooks are usually a bit smaller and lighter than a laptop. The newest ones often have the same capabilities as a desktop computer.
What is the Hubble constant?
Astronomers have always been interested in the age of our universe and the speed of various objects in space. The Hubble constant was devised by American astronomer Edwin Hubble, 1889 to 1953. It is the ratio of the recessional speed of a galaxy because the universe is expanding to its distance from the observer. In other words, the velocity at which a typical galaxy is receding from Earth, divided by its distance from Earth. The reciprocal of the Hubble constant is then thought to be the age of the universe, usually written in terms of kilometers per second per million light years. If the number is high, the universe would be very young. If the number is low, the universe would be much more ancient. Although there have been numerous theories, the true age of the universe is usually considered to be somewhere between 12 and 20 billion years old. The most recent agreed upon rate at which the universe is expanding is approximately 20 kilometers per second per 106 light years of distance. That makes the universe about 15 billion years old.
What is a percent?
A percent, using the symbol percent, is the ratio of one number to another. Percents are quantitative terms in which n% of a number is n1/100ths of the number. They are usually expressed as the equivalent ratio of some number to the number 100. For example, the ratio of 25 to 50 means the number 25 is 50% of 50. They are not true numbers. Thus, percents can't be used in calculations, such as addition or multiplication. But operations can be conducted with percents when they are translated into ratios and fractions. Such as 25% is equal to 0.25 or 1/4.
What are quartic equations?
Quartic equations are polynomial equations whose highest power of the unknown variable is 4. Put another way, quartic equations are algebraic equations whose highest exponent, or degree or order, is 4. For more about the history of solving quartic and cubic equations, see History of Mathematics. But take note, quartic equations are not the same as quadratic equations or second-degree equations in one variable, so don't mix them up.
What is a mathematical model?
Mathematical models are a way of analyzing systems by using equations, mathematical language, to determine how the system changes from one state to the next, usually using differential equations, and or how one variable depends on the value or state of other variables. Simply put, although working through the equations is not always simple, the process of mathematical modeling includes the input of data and information, a way of processing the information, and an output of results. A mathematical model can describe the behavior of many systems, including systems in the fields of biology, economics, social science, electrical and mechanical engineering, and thermodynamics. For example, modeling is usually used in the sciences to better understand physical phenomena. Each phenomenon is translated into a set of equations that describe it. But don't think that all the results of models are indicative of the real world, because it is virtually impossible to describe a phenomenon totally. Models are considered to be merely a human construct to help us better understand our surrounding real-world systems.
When was the calculating machine first mass-produced?
Between the 1624 invention of Blaise Pascal's calculating machine and 1820. There were about 25 manufacturers of such devices. Because there were so many, most had little funding and only one person involved. Very few machines were actually manufactured in any quantity. By 1820, the first calculating machine to be commercially successful and produced in large numbers was the arithmometer, invented by Frenchman Charles Xavier Thomas de Colmar, 1785 to 1870, while he was serving in the French army. It was based on a Leibniz step drum mechanism, see above. Colmar's machine used a simple system of counting gears and an automatic carry, automatically shifting a 1 to the left when the sum of a certain column was greater than 9. The technology of the times also helped catapult Colmar's success. Because it included springs and other machinery that offset the momentum of moving parts. The arithmometer stopped at a specific, intended point, unlike what often happened with the older calculating machines. One of his first ventures into calculating machines was the difference engine, which was based on Johann Müller's design and some of Thomas de Colmar's arithmometer features. For more information about both, see above. The idea was sound, but the execution eventually lacked government funding. Not to mention suffering from disputes with the artisan who was making the parts for the machine. Not only that, but Babbage's ambitions may have caused the difference engine prototype to come to a halt. Initially, he wanted the device to go to 6 decimal places and a second-order difference. Then he began planning for 20 decimal places and a sixth-order difference. This much larger machine was an overwhelming concept for its time. The abandonment of the difference engine did not stop Babbage, however. Again approaching the government for funding, he promised to build what he called the analytical engine. An improved device capable of any mathematical operation. Effectively making it a general-purpose, programmable computer that used punch cards for input. This new device would use a steam engine for power, and its gears would function like the beads of an abacus. With the main tasks of calculating and printing mathematical tables. For 8 years, he attempted to get more money from the government, but to no avail. He would never build his analytical engine.
What does a priori refer to in mathematical modeling?
The term a priori refers to the amount of information available in a system. Based on the amount of a priori information, mathematical modeling problems are often classified into white box. A system in which all necessary information is available. Or black box, a system in which there is no a priori information available, models. Practically all systems are somewhere between the white box and black box models, thus. This concept only works as an intuitive guide on how to approach a mathematical problem.
How do you convert from the binary to the decimal system and vice versa?
Besides the decimal system, one of the most familiar number systems is the binary numeration system. This is mainly because of its use in computers. For more about computers, see Math in Computing. In a binary numeration system, only 1 and 0 are used, or a base 2 system. Converting between binary and decimal systems is fairly simple. Just remember that each digit in the binary number represents a power of 2. The first column in the base 2 math is the units column, then the 2s, 4s, 8s, etc. columns, all of which can only be filled with 0s or 1s. Since there is no single digit that stands for 2 in base 2, when you get to what stands for 2, you put a 1 in the 2's column and a 0 in the units column, creating 1 2 and no 1s. Thus, the base 10 to 210, or just 2 in decimal form, is written in the binary as 102, a 3, 310, or just 3 in decimal form. In base 2 is actually 1 2 and 1 1, or 112. The number 4 is actually 2x2. So you eliminate the 2 and unit columns and put a 1 in the 4's column. Thus, 410, or just 4 in decimal form, is written in binary form as 1002.
How are the surface area and volume of a three-dimensional geometric figure calculated?
The surface area, often abbreviated S, A, of a three-dimensional geometric figure is the total surfaces of the solid. It actually has units of distance or length squared. For example, the surface area of a cube is 6a2, in which a is the length of the sides. To translate, a cube has sides of equal lengths, a. The area of a cube is the sum of the areas of the 6 squares, a2, that cover it. For more diverse figures, the surface area is actually equal to the lateral area plus the area of each base. For example, the surface area of a prism or cylinder is the lateral area plus the area of each base. Because the bases for a prism or cylinder are congruent, this is often expressed as twice the area of the base. The surface area of a pyramid or cone is the lateral area plus the area of the single base. The volume of a three-dimensional geometric figure is the total amount of space the object occupies. Volumes of such objects have units of length cubed. For example, the volume of a box, also called a rectangular parallelepiped, is length times width times height, or LXWXH. The volume of a cube is all the sides a cubed, or a 3.
What science fields use an abundance of mathematics?
The sciences that are heavy users of mathematics are the so-called physical sciences, including physics, chemistry, geology, and astronomy. These scientific fields are often contrasted with the natural or biological sciences. The physical sciences analyze the nature and properties of energy and non-living matter, and they often need the help of mathematics to determine the complex relationships between their interactions.
How is an aneroid barometer read?
Well, a falling hand on a barometer indicates a low pressure system is on the way with poor weather. Usually a storm with snow or rain. A steady barometer means there will be no changes with the ongoing pressure system. And a rising barometer means high pressure and fair weather. An even higher reading, around 31, means an extremely dry atmosphere. The timing of the barometric change is also telling. A change of a degree either way in a few hours means that the weather will change quickly. A slow change of 0.3 or so a day indicates weather arriving in 12 to 24 hours. A quick rise in the barometer also often indicates high winds and unsettled weather. All barometers work because of our weather systems. Changes in air pressure are caused by differences in air temperature. And this, in turn, creates the wind and weather patterns that carry. The high and low pressure systems around the Earth's lower atmosphere.
How did the concept of zero evolve over time?
The concept of zero developed because it was necessary to have a placeholder or a number that holds a place to make it easier to designate numbers in the tens, hundreds, thousands, etc. For example, the number 4000 implies that the three places to the right of the 4 are empty with only the thousandths column containing any value. Because zero technically means nothing. At first few people accepted the concept of nothing between numbers. Not that all cultures ignored the possibility of such an idea. For example, Hindu mathematicians, who wrote their math in verse, used words similar to nothing, such as sunya, void, and akasa, space. It is thought that the Babylonians were the first to have a placeholder in their numbering system, but not a zero. Instead, it appears they used other symbols, such as a double hash mark, also called wedges, as a placeholder. Archaeologists believe a crude symbol for zero probably started in Indochina or India about the 7th century and by the Mayans independently about 100 years earlier. While the isolated Mayans could not spread the idea of the zero, the Indians seemed to have no problem. Around 650 CE, zero became a mathematically important number in Indian mathematics, although the symbol was a bit different than today's zero. The familiar Hindu Arabic symbol for zero, the open circle, would take several more centuries to become more readily accepted. For more about zero and Hindu Arabic symbols, see History of Mathematics and Math Basics.
What are exponents?
Exponents are actually shorthand for multiplications and represent the number of times a number is being multiplied, called the base. For example, 9x9 equals 92, or 9x9x9 equals 93. Another term for this process is raising to a power, in which the exponent, a number as a superscript, is the power. For example, 93 is 9 raised to the third power. It is also easier to write larger numbers with exponents. For instance, instead of writing xxxx, we can write x4. For more information about exponents, see algebra.
What are formulas and equations in chemistry?
Formulas and equations in chemistry don't always mean the same as in mathematics. Formulas in chemistry are representations of a chemical compound using symbols for the elements and subscripts for the number of atoms present. For example, the chemical formula for water is H2O, in which there are two atoms of hydrogen, H, bonded to an atom of oxygen, O. The subscript 2 indicates that there are two atoms of hydrogen in the molecule. If there is no subscript number, as with the oxygen, O, a subscript of 1 is implied. Remember, not all compounds are molecular, for example, NaCl or sodium chloride. Regular table salt is called an ionic compound. In these cases, the formula shows the proportion of the atoms of each element making up the compound. There are other types of formulas in chemistry, but this is the most familiar. Equations in chemistry also differ from those in mathematics. Chemical equations represent the reaction relationship between two or more chemical compounds along with the products of the chemical reaction. For example, the chemical equation 2H2 plus O2 $2H2O is the reaction of hydrogen with oxygen to form water. The arrow indicates the direction of the reaction toward the product. The reactants, or the substances that react, are hydrogen and oxygen. There is also a methodology in writing chemical equations. Simply put, first determine the reactants and outcome, next determine the formula for each substance, and finally, balance the equation.
How did the metric system originate?
In 1791 the French Revolution was in full swing when the metric system was proposed as a much-needed plan to bring order to the many conflicting systems of weights and measures used throughout Europe. It would eventually replace all the traditional units, except those for time and angle measurements. The system was adopted by the French Revolutionary Assembly in 1795, and the standard meter. The first metric standard was adopted in 1799. But not everyone agreed with the metric system's use. And it took several decades before many European governments adopted the system. By 1820 Belgium, the Netherlands, and Luxembourg all required the use of the metric system. France, the originator of the system and its standards, took longer, finally making metric mandatory in 1837. Other countries such as Sweden were even slower. They accepted the system by 1878 and took another 10 years to change from the old method to the metric.
What is GIMPS?
GIMP stands for the Great Internet Mersenne Prime Search. A program started in January 1996 to discover new world record-sized Mersenne prime numbers. It harnesses the power of the internet and thousands of small computers belonging to public and private concerns to make the necessary calculations. GIMPs uses only about 8 megabytes of memory and about 10 megabytes of disk space. Per computer, a small amount of space for such a large undertaking. A Pentium-class computer is necessary, and the computer should be on most of the time. But if you decide to join the GIMPs group, be patient. A single test can take about a month to complete. To find out more, get on your computer, log on to the internet, and access the address http://www.mersenne.org/prime.htm.
What is a puzzle?
A puzzle is a mathematical problem that produces a solution, often in the form of rearranging pieces, often geometric, or filling in the blanks, such as a crossword puzzle. Puzzles do not typically require superior mathematical knowledge, but many originate from more advanced mathematical or logistical problems. They also include board games, such as chess, and brain teasers.
How does a person determine the odds in horse racing?
The track makes its money in a certain mathematical way, when the odds of the horse race are converted to probabilities. They usually add up to more than 1, giving the track the advantage. For example, say a racetrack has 12 races with 4 horses, and the odds of winning each race are as follows. Note: racetracks don't use the same horse in each race. This example is for illustrative purposes only. Horse 1-1:1, probability equals chances for 1 / total chances 1 + 1 equals 1/2 or 6/12. Horse 2-2:1, 1 / 1 + 2 equals 1/3 or 4/12. Horse 3-3:1, 1 / 1 + 3 equals 1/4 or 3/12. Horse 4-5:1, 1 / 1 + 5 equals 1/6 or 2/12. If a person puts $1 bets on horse number 2, he or she would have to win 4 out of 12 races to break even. But note, all these numbers add up to 15/12, or 1.25, a higher number than 1, so as long as no horse wins more than its probability, the house wins. There's another way of looking at this type of betting. In order for the gambler to do better than the track, he or she has to win 15 times in 12 races, a physical and mathematical impossibility, which is why the track always makes money. Of course, a gambler may bet on certain low-probability horses that win more races than expected, earning a few more dollars along the way, but don't bet on it.
What movies had mathematics as their primary focus?
The following 3 movies were either about mathematicians or had a dominant mathematical theme. A Beautiful Mind, 2001, based on the book by Sylvia Nassar, also see above. This is Hollywood's version of John Nash's rise, descent into mental illness, and eventual redemption. Directed by Ron Howard, it stars Russell Crowe and Ed Harris. Pi, 1998, this dark, low-budget, black-and-white film is about a mathematician's obsessive search for patterns in everything. While everyone from Wall Street investors to religious fundamentalists want to find and exploit him. Directed by Darren Aronofsky, it stars Sean Gullett and Mark Margolis. Infinity, 1996, this movie about the early life of brilliant and eccentric Nobel Prize-winning physicist Richard Feynman. 1918 to 1988, is both a tribute to the scientist and a whimsical romance. Directed by Matthew Broderick, it stars Matthew Broderick and Patricia Arquette.
What is an indirect proof?
Indirect proofs begin with a true statement and then proceed to prove that a conclusion is true. But there is also a method called the indirect proof in which indirect reasoning is used. First, assume that the conclusion is false, then show that this assumption leads to a contradiction of the hypothesis or some other accepted fact, such as a postulate or theorem. Therefore, if the assumption is proved false, the conclusion has been proved indirectly to be true.
How are positions on Earth determined?
Positions on Earth are determined using two numbers that represent latitude and longitude. These numbers are actually two angles, measured in degrees. Degree, minutes of arc, and seconds of arc. On a globe of the Earth, latitude lines circle parallel to the equator and differ in length depending on their location. The longest line is at the equator, latitude 0 degrees, the shortest lines actually pinpoints are at the poles. 90 degrees north at the North Pole, 90 degrees or minus 90 degrees south at the South Pole. In the Northern Hemisphere, latitude degrees increase as you move north away from the equator. In the Southern Hemisphere, latitude degrees increase as you move south away from the equator. Longitude lines, or meridians, once called meridian lines and eventually shortened to meridians, are those that extend from pole to pole, slicing the Earth like segments of an orange, with each meridian crossing the equator. In the Western Hemisphere, longitude increases as you move west from Greenwich, England, 0 to 180 degrees. In the Eastern Hemisphere, longitude also increases as you move east from Greenwich, England, again, 0 to 180 degrees. All points on the same line of longitude experience true noon, and any other hour, at the same time. But note, longitude lines are not to be confused with time zones, most of which follow a more erratic demarcation. For more information on time zones, see below. For more information about latitude and longitude with regard to polar coordinates, see geometry and trigonometry.
What is a limit in calculus?
A limit is a fundamental concept in calculus. Unlike a limit mentioned above, as in a series or sequence. A limit of a function in calculus takes on a somewhat different meaning. In particular, a limit of a function can be described as the following: if f, x, is a function defined around a point C, but may not be at C itself, the formal limit equation becomes lim f, x, equals L. Thus, the number L is called the limit of f, x, when x goes to C.
What are the square and square roots?
When you multiply a real or complex number by itself, you are actually squaring that number. Mathematicians express the square of a number using the superscript 2, or. For example, 22. The square of a real number is always positive. Whether the number is 22, equals 4, or minus 22, equals 4, a negative times a negative equals a positive real number. A square root is a number that when multiplied by itself equals a specific product. For example, if t2 equals s, then t equals plus or minus vs, in which t is the square root and s is a positive number. For example, the two square roots of 16, v1-6, are 4 and minus 4, as 42 equals 16 and minus 42 equals 16.
What is numerical weather prediction?
Numerical weather prediction is forecasting the weather using numerical models. Because of the complexity of the mathematics involved, not to mention the number of variables needed to predict the weather, all numerical model studies are run on high-speed computers. The computer solves a set of equations, resulting in a computer model of the atmosphere showing how weather conditions will change over time.
What is subjective probability?
As the word implies, a subjective probability is thought of as a personal degree of belief that a particular event will occur. An individual's personal judgment is not based on any precise computation, but is most often a reasonable assessment of what will happen by a knowledgeable person. This is usually expressed on a scale of 1 to 0, or on the percentage scale. For example, if a person's baseball team has a winning streak, they might believe that their team has a probability of 0.9 of winning the division championship for the year. More likely, they will say their team has a 90% chance of winning. Not because of any mathematical formula, but only because the team has had a winning record during the year.
How is mathematics used to describe population growth of organisms in a certain environment?
In general, a certain population of organisms from rabbits to humans will grow exponentially if it is left unchecked. That means that in a perfect world a population's rate of increase is constant. This can be seen in the following equations: after 1 year equals P0, 1 plus R. After 2 years equals P, 1 plus R, 2 after 3 years equals P, 1 plus R, 3, after n years equals P. 1 plus R, n, in which P0 is the population today and R is the rate of increase. These equations are further modified for population growth statistics. But such intricate calculations are not within the scope of this book. For more about population growth and biology, see above.
What is the casino's or house edge?
A casino is a gambling facility that normally includes all or a combination of the following: slot machines, video games, card games, and other games such as Keno, craps, and bingo. In order to make the casino the major money maker, not the gambler, there are certain rules of the casino, including the casino's edge, otherwise known as the house edge. The house edge is the ratio of the expected player loss to the initial amount bet. It is an exact measurement, usually expressed as a percent, of the casino's advantage in a game. A casino earns money by paying winners at house odds, an amount that is slightly less than the true odds of winning the game. There are definitely exceptions to this rule, which is why there are professional gamblers. But the majority of the time, the casino has the advantage. For example, if the house edge for blackjack or slots is 5%, then for every $100 bet initially made, the player can expect to lose $5. This not only helps the casino, but it is sometimes a way for patrons to compare one game to another, and even estimate how much they may lose. Of course, this is not always so straightforward. Some people win and others lose in the short run. But the casino always wins in the long run. There are also exceptions because of the way a game is played, such as in craps, see below. The best scenario would be to have no house edge, or an edge against the house.